In the following section, we will discuss electrical lighting. Lighting is basically one portion of electromagnetic waves flying through space, with a frequency and length. Light is emitted through incandescent, electronic discharge, electroluminescence, and photoluminescence. When replacing lights, always ensure you look at the efficacy. That's the lumens per watts emitted from the lighting system. You get a lot of inferior products at the same price as leading brands with high efficacy. So why would you want lower light output for the same power being paid? That is the main reason why low lux levels are witnessed within the plant and within office environments. The quality of the lighting is not up to standard or has decayed with time. Remember, LED lights do not just blow out like the old lights used to do. They lose lighting output over time until eventually they produce no light. It's always important to understand the lighting design qualities. If we use quantity as a sample, we might over-design or undesign. We have to make sure that we've got the right amount of fittings in, the right luminaires, and we take into account the degradation of the lighting over time. The quality of the light is also important, as this highly impacts the color rendering index and the coloring temperature. It also produces visual glare, or you also get lights that have little visual glare. Let's look at a few lighting sources. We have incandescent light, tungsten lights, fluorescent, high intensity discharge, induction lighting, laser lighting, and LED lighting. At Formosa Textiles, most of the lighting witnessed and inspected were LED lightings, although they have started to decay quite badly. When looking at lighting sources, fluorescent lights for example, the efficacy is about 30 to 90 lumens per watt. And we also have a ballast that increases the losses within the lighting system. If we move over to LED lights, our efficacy is about 30 lumens per watt in 2008. 2011 it moved to 62 lumens per watt. 2014 97 lumens per watt. And now we're sitting with 160 plus lumens per watt. Perhaps it's time for Formosa Textiles to consider a lighting upgrade in order to comply with the occupational health and safety regulations regarding the lux levels witnessed within the plant. To clear up a few factors, let's look at lighting terminology. Luminous intensity is the ability of a source to produce light in a given direction. Luminance flux is the total amount of light. Illuminance is the amount of light received on a unit area of surface. Luminant existence is the density of light reflected or transmitted from a surface. And luminance is the intensity of light per unit of area reflected or transmitted from a surface. In this slide, we can see that LED is the best when it comes to lumens per watt, and this cannot be beat. The only factor coming into play is deterioration. So, looking at color rendering index and the quality of the light received, a 75 to 100 color rendering index is excellent color rendering, and 0 to 55 is poor color rendering. The color temperature, there's also warm white versus cool white spectrum. It needs to be decided what is required within the plant. For detailed inspection, a high color rendering index is probably more suitable. In this slide is a chart of the color rendering index showing the difference, where 100 is the closest to natural light and 0 is low pressure sodium. Similarly, color temperature can be displayed in this chart, where we get warm white usually in the 4000 Kelvin range and cool white usually 4200 and above. Let's look at some quick recommended lighting levels. In a parking lot, we need about 20 lux. Covered parking for the OSH Act and SANS 50 and 75 lux respectively. Hallways 100, factory floor 300, offices 500, inspection 1000, and operating rooms 10,000. Next, let's have a look at a few opportunities. So, switch off unnecessary lights. As it's already highly done at Formosa Texons, there's always an opportunity to improve this. We can control these systems automatically and manually. We can also remove redundant fixtures. In storage areas or areas where there's very little movement, there's no need for lighting to stay on. We can relamp lighting fixtures to get better lux on the readings on the surface areas of work. We can clean, replace, and even modify fixtures in order to ensure that effective lighting is achieved. Remember, the light output from all light sources, LED, halogen, metal halide, and fluorescent, decreases over time. The amount of light from the light source at a specific time in the future is referred to as a lumen maintenance factor, or LLMF. The lifetime of a LED module is defined as the time it takes until the light output or lumen maintenance reaches 70% of the initial output. This is also called L70. In other words, the module does not die instantly as many conventional light sources do. It just slowly dims down.